We've talked about this idea in class a little bit, and the idea is that my robot will start at position 0. So what we're trying to do is we're trying to figure out if my robot keeps on turning, when do I know that the robot's definitely turned too much and we're probably now facing the wrong way. And if my robot does a scan and it sees a path on the right side and on the left side, can I have it think to itself, oh, well, I need to turn left to get back towards my 0 heading, my original heading. So what it would look like is this. If every time I take a right, I would, let's say, subtract the same amount that I encoded. So if I did self.encode right by 5, I would subtract 5. And then let's say I did later on self.encode left by 6, then I would add 6 because I am now back turned a little bit this ways. And so I would now be at a positive 1. And so I know if I wanted to even myself back up, I would do self.encode right by 1, and that means I'm back heading straight. So how can we keep track of this? Well, we can make a turn track variable and start it out at 0. So that would look like this. Let me pull that up. So I'm in my student method, and I'm going to add in a turn track variable, and we'll start it out at 0. So that's it. So now self.turnTrack is equal to 0. Now every time that I use encode right or encode left, I want to adjust this number and maybe print it as well, so I can test it to see if it's working. I'm going to show you something tricky and something kind of cool, but before I do, I want to bring up what I could do is I could edit these encode right. You see how we have self.encode right, which calls a bunch of the GoPiGo methods, waits for you to be able to turn and stops after your turn, and prints some information so it's easier for you to track as well. We could copy these over into our student method and then add a new line that says to adjust that variable that we just created. But a cleverer way of doing it is like this. If I create a new encode right, and then I say super, and what the super means is I know my parent, so student's parent is the PyGo. Super says, I know my parent, which is this guy, has an encode right. So call that and use my, I'm not talking about a different GoPiGo. I'm talking about myself. So find my parent's encode right and do that for me. And then after that, well, maybe before that, I'll just do self.encode right. No, sorry, self.turnTrack is minus equals. So take its current value and drop it whatever it is that I turned. And now I'll just copy and paste this guy. And this should be turn left and turn left, and this is plus equals. So, and I can add it in a print statement. Well, here actually I can so I guess if self.turnTrack, okay, try that out. So if my turn track is positive, which means that I'm facing, it's gone this way, then that means I need to turn right to get to face the exit. So right here it's saying if it's positive, then the exit is to my right by however much the turn track is. And since this is a number and it's being included in a string, I convert it into a string here. So the exit is to my right by blank units. So whatever an encode unit would translate to. Okay, so and I can add something similar to this. Oh, actually, you know what? I can also add an else statement. Else to my left by. Now the problem with this is this is going to be a negative number by -5 units or whatever. I could just turn this into, I could just take the absolute value of this number. Oh wait, I need to take the absolute value of this number and then turn it into a string. So take the absolute value of this number and then turn it into a string so it can fit into this. And I think that should work. Now the exception is that if it's already, you know, dead straight, then this is going to say, you know, because this is less than. If it's equal to, then it'll say by left by 0 units, which is fine. Cool. So I'll add that there. Now I'm pretty sure this will work. Totally looked it up about how it should work. So that should. So if you give this a try, then every time your robot turns, it'll print how much it needs to turn in order for it to be right on track. I don't have a GoPiGo with me, so I can't test to see if this works, but we can try. And then the next thing to test, if this works, the next thing is going to be able to learn about your robot using the using this rotate method to measure exactly what each encode unit, how that translates to degrees. And so if you can get the relationship between one encode and however many degrees that is, if you can figure that out, then we can figure out how much we want to turn. But at the moment, that's a later problem. Let's first start right away by seeing if we can track accurately how much we need to turn in order to get straight.